National Electrical Code Section 725.121 addresses the installation of Class 1 circuit conductors with Class 2 and Class 3 circuit conductors. It states that cables and conductors installed as part of a Class 1 circuit shall be permitted to run in the same raceway, cable, box, or enclosure with Class 2 and Class 3 circuit conductors, given that all conductors are insulated for the maximum voltage of any conductor within that raceway, cable, box, or enclosure. This provision allows for the combination of different types of circuits within the same enclosure under specific conditions, primarily focusing on ensuring adequate insulation for the highest voltage present. National Electrical Code Sections 300.3 and 300.4 provide further guidance on the installation of conductors. These sections generally stipulate that conductors of different systems, such as power and control circuits, should not be installed in the same raceway unless the raceway and the conductors themselves are specifically identified and suitable for this combined use, while also being appropriate for the voltage and current levels involved. This requirement ensures that the electrical system's integrity is maintained when combining different types of circuits. Given these code sections, installing control wires alongside power conductors is acceptable, provided certain conditions are met. Firstly, the control wires must be insulated to withstand the maximum voltage present in the power conductors. This is crucial for preventing insulation breakdown and potential short circuits between the different circuits. Secondly, the raceway or enclosure used must be deemed suitable for the voltage and current requirements of all conductors contained within it. This ensures that the enclosure can safely handle the electrical loads and provides adequate protection. Thirdly, the raceway must be of sufficient size to accommodate all conductors without exceeding the fill limits outlined in National Electrical Code Section 300.17. This provision prevents overcrowding, which could lead to overheating and insulation damage. Finally, the control wires should be physically separated from the power conductors by a barrier or partition whenever possible. This added layer of protection minimizes the risk of physical damage or interference between the two types of circuits. Beyond these code requirements, several additional considerations should be taken into account when installing control wires with power conductors. One significant factor is electromagnetic interference, often abbreviated EMI. Power conductors can generate electromagnetic interference, which can disrupt the operation of nearby control wires. To mitigate this risk, it is recommended to use twisted pair shielded control cables. The twisted pair design helps to cancel out electromagnetic fields, while the shielding provides an additional barrier against interference. Another key aspect is physical protection. Control wires should be carefully routed to minimize the risk of damage from the power conductors. This includes avoiding sharp bends, securing the wires properly, and protecting them from abrasion or vibration. Proper physical protection ensures the long-term reliability of the control circuits. Additionally, it is important to label the raceway or enclosure clearly to indicate that it contains both power and control conductors. This labeling provides a warning to electricians or technicians who may be working on the system in the future, helping them to take appropriate precautions. By adhering to these guidelines, the installation of control wires with power conductors and systems can be done safely and in compliance with the National Electrical Code. The main points that needs to be considered are firstly, insulation, secondly, raceway suitability, thirdly, fill limits, fourthly, physical separation, fifthly, electromagnetic interference mitigation, sixthly, physical protection, and seventhly, proper labeling. Considering insulation, it's crucial to use control wires with an insulation rating equal to or greater than the highest voltage present in the power conductors. This prevents insulation breakdown and potential short circuits. For raceway suitability, select a raceway type approved for the voltage and current levels of both the power and control conductors. Metallic raceways provide better shielding against electromagnetic interference. When it comes to fill limits, the National Electrical Code specifies maximum fill percentages for different types of raceways. Ensure that the combined cross-sectional area of all conductors does not exceed these limits. With physical separation, using barriers or partitions within the raceway to separate power and control conductors minimizes the risk of accidental contact or damage. To mitigate electromagnetic interference, employ shielded twisted pair cables for control wires. Ground the shield properly to drain away induced noise. As for physical protection, route control wires away from sharp edges, sources of heat, and areas prone to vibration. Use cable ties or straps to secure the wires in place. Finally, for proper labeling, clearly label the raceway or enclosure indicating the presence of both power and control conductors. Include voltage and current ratings where applicable. To elaborate on National Electrical Code Section 300.3, it's essential to understand the implications of mixing different voltage systems within the same raceway. The code emphasizes that the raceway and conductors must be identified for the specific purpose of accommodating multiple systems. This identification often involves specific markings or listings that indicate the equipment's suitability for such applications. Furthermore, the equipment must be rated for the highest voltage present in the raceway to ensure safety and prevent installation failure. National Electrical Code Section 300.4 focuses on the protection of conductors from physical damage. When running control wires alongside power conductors, it's crucial to protect the control wires from abrasion, cuts, or other forms of mechanical stress that could compromise their insulation. This can be achieved through various methods such as using raceways, installing barriers, or employing additional layers of insulation. The specific protection method will depend on the application and the potential risks involved. When considering electromagnetic interference, it's important to understand the sources and characteristics of EMI. Power conductors carrying alternating current generate electromagnetic fields that can induce currents in nearby control wires. These induced currents can interfere with the operation of sensitive electronic equipment connected to the control wires. Shielded cables are designed to block or attenuate these electromagnetic fields, reducing the amount of interference that reaches the control wires. The effectiveness of shielding depends on factors such as the type of shielding material, the shield's thickness, and the grounding method. Proper grounding is essential for draining away the induced currents and preventing them from causing interference. Regarding the installation of control wires in a UPS system, it is important to consider the specific requirements and recommendations of the UPS manufacturer. The manufacturer's instructions may provide additional guidance on wiring practices, grounding techniques, and electromagnetic interference mitigation strategies. Following the manufacturer's recommendations ensures that the UPS system operates reliably and safely. When labeling the raceway or enclosure, it is important to use clear and concise language that is easily understood by electricians and technicians. The label should identify the presence of both power and control conductors, along with the voltage and current ratings of each system. This information helps to prevent accidental contact or damage to the conductors during maintenance or repair activities. In addition to the code requirements and best practices, it is also important to consider the long-term reliability and maintainability of the electrical system. Proper planning and installation can minimize the risk of future problems and make it easier to troubleshoot and repair the system when necessary. This includes using high-quality materials, following industry standards, and documenting the installation thoroughly. For example, consider a scenario where control wires for a remotely located maintenance bypass panel board need to be installed alongside 480 volts power conductors. In this case, the control wires must have an insulation rating of at least 600 volts to match or exceed the voltage rating of the power conductors. The raceway used must be listed for use with both power and control conductors and must be large enough to accommodate all conductors without exceeding the fill limits specified in National Electrical Code Section 300.17. Furthermore, shielded twisted pair cable should be used for the control wires to minimize electromagnetic interference, and the shield should be properly grounded. The raceway should be clearly labeled to indicate the presence of both power and control conductors. In another example, suppose control wires for a lighting control system need to be run alongside 120 volts power conductors in a commercial building. In this scenario, the control wires must have an insulation rating of at least 300 volts, which is the standard insulation rating for general purpose wiring. The raceway used must be suitable for the voltage and current levels of both the power and control conductors. It is important to note that the specific requirements for installing control wires with power conductors may vary depending on the application, the voltage levels involved, and the local electrical codes. It is always recommended to consult with a qualified electrical engineer or electrician to ensure that the installation complies with all applicable requirements and best practices. When working with electrical systems, it is essential to prioritize safety at all times. This includes wearing appropriate personal protective equipment, following lockout/tagout procedures, and verifying that the power is off before working on any electrical equipment. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents or injuries. In summary, installing control wires with power conductors is acceptable under specific conditions outlined in the National Electrical Code. These conditions include ensuring proper insulation, raceway suitability, fill limits, and physical separation. Additionally, it is important to consider electromagnetic interference mitigation, physical protection, and proper labeling. By following these guidelines, you can safely and reliably install control wires with power conductors in a variety of applications. Always consult with qualified professionals and adhere to local electrical codes to ensure a safe and compliant installation. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date with the latest requirements. The National Electrical Code is updated every 3 years, and it is the responsibility of electrical professionals to be aware of these changes. Continuous education and training are essential for maintaining competence and ensuring the safety of electrical installations. Also, consider the environmental conditions in which the electrical system will be operating. Extreme temperatures, humidity, or corrosive environments can affect the performance and lifespan of electrical components. Select materials and equipment that are suitable for the specific environmental conditions to ensure long-term reliability. Consider the future expansion of the electrical system. It may be necessary to add more circuits or equipment in the future, so it is important to plan for this during the initial installation. This includes providing adequate raceway capacity, spare conductors, and sufficient panel board space. Proper planning can make future expansions easier and more cost-effective. Before commencing any electrical work, it is important to obtain all necessary permits and approvals from the local authorities. Electrical permits ensure that the installation complies with all applicable codes and regulations. Failure to obtain the necessary permits can result in fines or other penalties. When selecting control wires, consider the type of signal being transmitted. Some control signals are more susceptible to interference than others. For example, analog signals are generally more sensitive to noise than digital signals. Select control wires with appropriate shielding and insulation characteristics for the specific signal being transmitted. When installing control wires in a raceway, avoid sharp bends or kinks. Sharp bends can damage the insulation and reduce the current carrying capacity of the wire. Use appropriate bending tools and techniques to ensure smooth, gradual bends. When terminating control wires, use appropriate connectors and terminals. Ensure that the connections are tight and secure to prevent loose connections, which can cause overheating and electrical faults. Follow the manufacturer's instructions for terminating the wires and using the connectors. When grounding control wires, follow the grounding requirements outlined in the National Electrical Code. Proper grounding is essential for preventing electrical shock hazards and minimizing electromagnetic interference. Use appropriate grounding conductors, bonding jumpers, and grounding electrodes. After completing the electrical installation, perform thorough testing and inspection to ensure that everything is working properly and that all safety requirements are met. Use appropriate test equipment to verify voltage levels, current flow, and insulation resistance. Document the test results and keep them on file for future reference. Periodically inspect the electrical system to identify any potential problems or hazards. Look for signs of damage, overheating, or loose connections. Address any issues promptly to prevent more serious problems from developing. Regular maintenance and inspection can help to ensure the long-term reliability and safety of the electrical system. Remember that electrical safety is everyone's responsibility. If you are not qualified to perform electrical work, do not attempt to do so. Hire a qualified electrician to handle any electrical tasks that you are not comfortable with. Your safety and the safety of others depend on it. When working with electrical equipment, always follow the manufacturer's instructions and safety precautions. Failure to do so can result in serious injury or death. Be aware of the potential hazards associated with electrical work and take all necessary precautions to protect yourself.